In this session, we'll be learning how to connect a solar panel 10 watts, solar charge controller 12 volts 10 ampere, solar battery 12 volts 100 ampere hours and a normal inverter and convert to a solar inverter. At the end of this session, you'll be able to understand the fundamental principles and components of a solar panel, define the role and importance of inverters in solar energy systems, including their function of converting direct current DC from solar arrays to alternating current AC. Describe different types of inverters and their usages and understand the critical factors contributing to the success of solar PV integration projects.
Let us learn about solar panel firstly. A solar panel consists of many solar cells with semiconductor properties encapsulated within a material to protect it from the environment. These properties enable the cell to capture light, or more specifically, the photons from the sun, and convert their energy into useful electricity through a process called the photovoltaic effect. An inverter is an electrical device which accepts electrical current in the form of direct current DC and converts it to alternating current AC. For solar energy systems, this means the DC current from the solar array is fed through an inverter which converts it to AC. This conversion is necessary to operate most electric devices or interface with the electrical grid. Inverters are important for almost all solar energy systems and are typically the most expensive component after the solar panels themselves. Firstly, let us learn about standalone SPV system. Standalone SPV system is normally preferred in places where electricity is not available. Hence, it is suitable for remote areas, land or water bodies where grid supply is not available. Examples: border military service camps, naval services, farmhouses, mountains, forests, resorts, etc. The main components include battery backup and inverter. An AC main from grid is not used. Solar energy, the only source, is used to charge the battery bank and daylighting. During night, battery provides the energy input to inverter. Loads are normal AC loads and can be any. DC loads also can be used after charge controller. No AC output when battery bank voltage goes below its designed value. When we add an option of additional source of charging to the standalone solar PV system, we get the hybrid inverter based SPV system. Solar energy is the main source for charging the battery. Additional energy requirement is supplemented by AC mains. An auxiliary charging circuit helps charge the battery in the absence of solar energy. In the absence of sunlight, either partially or totally, and while the system is not able to supply AC power to load, then the additional energy is drawn from AC mains. AC mains power is converted to DC power by rectifiers to supply additional energy input to the battery. Diesel generator is also one of the choices in the absence of AC mains power. Both AC mains and diesel generator are non-renewable. Other renewable energy sources such as wind or hydro may also be used to expand the scope of hybrid SPV systems. Priority of charging starting from 1 to solar energy, followed by other sources, can be set by including electronic circuits in the input of battery bank. The success of the solar PV integration lies with proper planning and execution of the project. It needs accurate design of the complete plant, adequate knowledge of available technology, components variations, market provisions, manufacturers around, import essentials, logistics, manpower requirement, etc. supports the design team. PV system software is one such tool which simplifies the work of the design team to great extent. It even starts from analyzing solar irradiation location-wise and guides best approach for designing. A lot of financial decisions are taken based on the simulation report which is given as an output by the software. PV system software is designed to be used by architects, engineers and researchers. It is also a very useful educative tool. It includes a detailed contextual help menu that explains the procedures and models that are used and offers a user-friendly approach with a guide to develop a project. PV system can import metadata as well as personal data from many different sources. PV system presents results in the form of a full report, specific graphs and tables, and data can be exported for use in other software. The system design is based on a quick and simple procedure. Specify the desired power or available area. Choose the PV module from the internal database. Choose the inverter from the internal database and PV system will propose an array or system configuration that allows you to conduct a preliminary simulation. This software embeds a color-coded warning or errors messaging system. If there is a mismatch, issue, warning with your design, you will be warned within the proper frame. There are other software available over the internet similar to the above. We can select, purchase and use for designing the solar PV plant. Study the inverter wiring diagram and connect the components of the solar inverter. Ensure you have all the following tools and equipment. 12-volt DC or 230-volt AC normal inverter, solar panels 75 watts, 2 numbers, charge controller, connecting wires, load bank, 12-volt 100 ampere hour battery and clamp meter. Wiring sequence are as follows. Wire the charge controller. Connect charge controller to battery. Connect battery to inverter. Connect panel to charge controller. Connect loads. Keep all MCB in off position and fuses removed for safety. Follow the testing sequence of the inverter and test the solar inverter in a similar way for normal load, full load and overload conditions. Record the observations.
We have reached the end of this session on Connect a solar panel 10 watts, solar charge controller 12 volts 10 ampere, solar battery 12 volts 100 ampere hours and a normal inverter and convert to a solar inverter. By now, you should be able to understand the fundamental principles and components of a solar panel, define the role and importance of inverters in solar energy systems, including their function of converting direct current DC from solar arrays to alternating current AC, describe different types of inverters and their usages, and understand the critical factors contributing to the success of solar PV integration projects.